Hi everyone, in this video I'm going to be showing you how to solve problems involving addition and subtraction with fractions, and in this video we're going to be focusing on fractions with the same denominators. Okay, so here I can see both denominators are 8, which means we have 5 eighths here, and we're going to add on another 6 eighths. So I'm going to use a model here to show this. In here, I've already split this into 8 sections, and I've shown 5 eighths here in green. And now all I need to do is add on 6 of them. So I can see, if I'm going to add 6 eighths, there's 3 more. I need to add 3 more on. So what I'm going to have to do is then split this whole into 8ths as well. So if I halve it, I could halve again, and it might not be perfectly accurate, but it's pretty close to. And then I could halve my quarters to make eighths. Now I can add on more. And I've already added on 3 eighths, so I need 3 more. So I can see now that I had 5 eighths to start with in green. I've added on 6 more eighths. For my answer, there's 2 different ways I could write this. I could say that altogether, I have 8 eighths and 3 more, makes 11 eighths. I could also write that as a mixed number, because I've seen here there's 1 whole here with 3 more eighths. So I could write that as 1 and 3 eighths. Okay, let's have a look. So just to recap, actually, before we do that, you could show this using models to add on, but what you might notice is that all that's changed is the numerators. A denominator does not change because we're still counting how many eighths there are. We have 11 eighths, which would be the same as 1 whole and 3 eighths. Let's have a look down here. This one says, we could read this as 10 sixths, take away 7 sixths. So to start with, I could split my whole into thirds. So if I estimate that a half is about there, a third is a bit less than a half. And then if I halve my other section, I will have thirds. If I halve my thirds to make sixths. I'm going to have to do that again because I need 10 sixths. There's only 6 sixths in here. So I can literally just copy those lines down because they should be the same size. Okay, and there's the other one there. If I start with 10 sixths, I'll make 10 sixths green. I can color in 1, 2, and 6 would be in this hole. So there's 6, 7, 8, 9, 10. We're going to take away 7 of them. So to show the subtraction, you could rub them off. However, then it's just going to look like in your model they were never 10 to start with. So what I'm going to do is I'm actually going to cross out 7. So I'm going to show 7 in orange. And I could say, I'll probably start from down here actually. Take away 1, 2, 3, 4, 5, 6, 7. 6 have been subtracted, which would leave me with 3 parts out of 6 left over, or 3 sixths. Whoops, I'll fix up that. 3 sixths left over. And you could even simplify that if you wanted to say that's the same as a half. But if we come back to looking at just here, again, we can see the denominator has not changed. It's still 6, and we've taken 7 from 10 to make 3. So the key point is to remember that when you're adding and subtracting fractions with the same denominators, the denominators do not change. We either add the numerators or we subtract the numerators. And if you can, you should always simplify your fraction, or if you can write it as a mixed number, do that as well. Thanks.